And here we are at sound part 2. Thank you, Snagit, for crashing yet one more time. Sound waves can interfere with one another. You've probably heard, as I was saying at the end of part 1, you've probably heard of white noise machines or sound canceling earphones. Well, the way that works is this. When you have sound waves, if you have two sound waves that are running parallel to one another, they can actually amplify one another, and so what you end up with is the red and the blue amplitude here are combined, and so you end up with this green amplitude. So sound waves are additive. So sound waves can be additive. Two or more waves combine, and you get this constructive interference, so that you get this a higher amplitude because both sounds have the same period. Okay, both sounds have the same frequency. So the total wave is enhanced, and so you get a louder sound. Also, you could have destructive interference, and this is where you get noise canceling headphones. If I have wearing a pair of headphones that measures the sound that's coming into it and then inverts that sound and creates a sound that is off by exactly half the wavelength, then where one wave has a crest, the other wave has a trough, and so the sum of the two lines is 0. And so what you end up with is you have noise canceling headphones or noise canceling device that is canceling the sound by way of wave interference. So you'll get less sound or no sound. So here's that again. You can have constructive interference where it increases the amplitude, or you could have destructive interference where when the crest and the trough are offset from one another, then what you get is little to no sound. Now, that's what it looks like if you're visualizing it as a transverse wave, but if we look at it as this longitudinal wave, we can see what happens. You get more of a rarefaction here, more of a compression here, but you get very little compression and lots of rarefaction in the destructive part. So when waves interfere with one another, you could have this this system where you actually cancel out sounds. Now, the velocity of sound in air is going to, as we've said before, it varies with temperature. In warm air, because you already have a great deal more kinetic motion with the particles in the air, you're going to transmit sound from molecule to molecule or from particle to particle more rapidly in warm air. And so greater kinetic energy. So sound impulse travels faster in warm air, whereas in colder air it travels more slowly. So you can also have sounds coming from moving sources. Okay, this sounds coming from moving sources. Think about this. If you have a moving source that is coming towards you, then those wave fronts are going to hit you more often as it's coming towards you. So it's going to, as the closer and closer it gets, the wave fronts are going to hit you more and more often. So that's going to change the pitch of the sound as you're listening to it. That's going to change the pitch of the sound as you're listening to it. If it's moving away from you, you're going to get exactly the opposite. And this is called the Doppler effect. And you've all experienced the Doppler effects whenever you hear a police car or an ambulance approaching your car and then driving away from your car. As it's approaching you, the frequency increases, and so the pitch increases. And then as it's moving away from you, the pitch decreases because the frequency is decreasing. You've also heard this. Every one of you have seen little boys, particularly, playing with little cars. Yeah, that's the sound that they're making. You know, as the car comes closer to you, it's making it louder. You know, the pitch is increasing to a higher pitch and getting louder also, and then it's moving away from you, so the pitch is decreasing. So this is called the Doppler effect. Interestingly enough, even though we didn't talk about it with light, The Doppler effect also is true for light. It's one of the ways that we can determine whether or not a star is moving towards us or moving away from us. So here are some websites that you can take a look at. And again, take a look at these. The links will be active in the lecture, the slide deck that is not recorded. And with that, we will end our look at sound.